In today's video, you are going to learn about valence electrons. Valence electrons. You are going to learn about non-valence electrons. Non-valence electrons. You are going to learn about electronic configuration. Electronic configuration. And lastly, you are going to learn how to relate these terms with the periodic table. Relation with the periodic table. So these are your objectives for today. By the end of today, you should know what valence electrons are, what non-valence electrons are, what electronic configuration is, and how to relate these terms, valence electron, non-valence electrons, electronic configuration, with the periodic table, how they are related. Valence electrons. What are valence electrons? Actually, in my last video, I did explain how the structure of an atom is. An atom is having a centrally located nucleus, and on that nucleus we have shells. And these shells are filled with electrons. Electrons are filling all these shells, and this nucleus contains two subatomic particles, which are protons and neutrons. Electrons are moving around the nucleus in what we call energy levels or shells. And we could have many shells there. We could have many shells depending on the nature of the atom. Yes, if it's a simple atom like hydrogen, we'll have only one shell. But if it's a complex atom or element, we have many shells, and those shells are all filled with electrons. Now, all these electrons which are being filled on the shells are classified into two: valence electrons and non-valence electrons. Valence electrons are those electrons that you find on the outer shell of an atom. Those electrons that you find on the outer shell, you count all the electrons on the outer shell, you consider them as valence electrons. Why non-valence electron, which is the reverse? Non-valence electrons is all about the various electrons found on the atoms apart from that in the outermost shell. So you count any electrons which you have seen in the atom, all the shells apart from the last shells. That is what you consider as non-valence electrons. Non-valence electrons is also known as core electrons. So when you hear about core electrons, you should know that they are talking about non-valence electrons. All those electrons in the atoms apart from that in the outermost shell. Now let's do an example. For example, let me take hydrogen, a simple atom. Hydrogen. Yes, can you draw the structure of hydrogen atom? Let's do that. So hydrogen is having a centrally located nucleus. This nucleus is containing protons and containing neutrons as well. So on the outermost shell, you have one electron, because hydrogen is having an atomic number of 1. Atomic number is 1. Proton number is 1. So atomic number is related to proton number. When you know the atomic number, you have known the proton number. So it's having 1 proton. And in my last video, I said that protons are always equal to electrons in a neutral atom. So if you have 1 proton here, you should have 1 electron outside here. Yes, if you have 1 proton here, you should have 1 electron. So what are the core electrons of this atom? This atom is not having any core electron. It's having a valence electron, which is 1, no core electrons. Coming to an atom like sodium, let's talk about sodium. Natrium. It's coming from the Latin word natrium, sodium. Okay, let's draw the structure of a sodium atom. So to draw the structure of an atom, you have to know the total number of its electrons or its protons. Yes, as protons are related with the electrons, protons are the same as electrons. So know the number of protons it has. And of course, proton number is simply the position of that element on the periodic table. Where is sodium located? What position is sodium on the periodic table? Sodium is on position 11. That is having a proton number or electron number of 11. So let's fill up that electrons in the shell. This is a centrally located nucleus. Face shell, let me draw this. I'm going to explain this later. This is a face shell of sodium. This is a nucleus. I'm going to explain how I'm drawing this later. This one is known as the Bohr model of electron filling. Yes, you can count from here. These are the number of shells. You have how many shells? 1, 2, 3, and you have a nucleus. How many electrons do you have altogether? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have 11 electrons. Now, among these electrons, how many core electrons or how many non-valence electrons do we have? We have only this as a valence electron. You have only 1 valence electron. So valence electron is equal to 1 for sodium. And how many core electrons? Pause and give me the answer in the comment section. How many non-valence electrons? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 non-valence electrons or 10 core electrons in sodium. Non-valence electrons, you have 10, and valence electron is 1. That is how we can know valence electrons and non-valence electrons. Valence electrons, the number of electrons on the outermost shell of an atom, and non-valence electrons, the number of electrons in an atom apart from that in the outermost shell. Considering you have known this, these electrons are always very important. These valence electrons are very important because they determine the reactivity of an atom. How reactive an atom is depends on the valence electrons. They take part in what we call bonding or combination. You know, atoms are always unstable. They are not always stable. So they try all possible ways to be stable. They want to be stable, and for them to be stable, they can either share electrons with some other atoms to be stable. They can either donate electrons, give out electrons, or they can either receive electrons, share electrons, donate electrons, or receive electrons to be stable. That is how atoms obtain stability. And these electrons that are being shared are only the valence electrons. Core electrons do not determine the reactivity of an atom, only valence electrons. Now let's talk about electronic configuration. That is our next objective, electronic configuration. What are electronic configuration? I already started interpreting some examples of electronic configuration up here, which was sodium. Electronic configuration, abbreviated as EC, is simply a pattern in which electrons need to be filled on the shell of an atom. Electrons are not always being filled randomly in an atom shells. It follows a general pattern, and that which was proposed by Niels Bohr, a great scientist, and scientists are still using that same pattern to fill electrons on the shells of atoms. And based on his postulate about how electrons are supposed to be filled on the shells, he said that the first shell, the very first shell beside the nucleus of an atom must take a maximum of 2 electrons. The first shell after the nucleus, it must take a maximum of 2 electrons. And he went further by saying that the second shell must take a maximum of 8 electrons maximums, and the third shell can take 8 as well, 8 electrons. Yes, that is how Niels Bohr proposed that we should be filling electrons, and that is being used today. I did mention about shells earlier. Let's talk about shells again. This is the nucleus of an atom, the nucleus. So the first one, you have the first shell outside the nucleus. This one is the first shell. The first shell, as you are going out of the nucleus, the first shell. The second shell continues. The third shell continues, and so on. You could have many other shells depending on the stability or the structure of that atom. Let's talk about how the shells are being filled now. This is the first shell. Let me label it first shell. This is the second shell, and this is the third shell. Yes, these are the shells of atoms. Niels Bohr said that the first shell must take a maximum of 2. It should not be more than 2. You should not fill 3 electrons on the first shell. So let's fill 2 electrons here. I will fill it like this. These are 2 electrons. 1, 2. The second shell must take a maximum of 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. It's now completed. Yes, it's completed. You should not add more than this. That is why you saw me writing 8 electrons on these shells I was filling up here. And the third shell should take a maximum of 8 electrons as well. But in some situations, you notice that some electrons will not be enough to fill up these shells. Some of the shell, most likely the last shell, the outermost shell, this is what is called the outermost shell. The outermost shell is the shell outside, and the innermost shell is the shell beside the nucleus. So the first shell is called the innermost shells. Like I was saying, some of the electrons might not be sufficient to be filled up completely in an atom. So that atom will be considered to be unstable. It's not stable. For it to be stable, all its shell has to be filled. The first shell must take 2 electrons. Second shell must take 8. The last shell must take 8. So if this is not implemented because of electrons, because of lack of electrons, it means that that atom is unstable. It's not stable. There is a need for it to be stable by combining, by combination, by either sharing electrons with some other atoms, by either gaining electrons from some other atoms, or giving out electrons. These are the 3 ways in which an atom can obtain stability: by sharing, giving, or taking. So any atom that exists has its electronic configuration. And this electronic configuration are also written using numbers. We use numbers to represent these electrons, and separated by either columns or commas. Yes, so electrons are written like this. Let me say, if I'm using a number, I'll use 2, either use comma, 8 and 8. This is the electronic configuration from this electron filling. 2, 8, 8. It means that the first shell I've taken 2 electrons, the second shell I've taken 8 electrons, and the third shell I've taken 8 electrons. Or I can still use this 2 is to 8 is to 8. That is how we can represent electronic configuration using either commas separated by commas or by column. Now, for you to write the electronic configuration of any atom, you have to know its number of electrons so that you are going to use that to fill in the shells of that atom. Are you getting me? Yes. I took an example with sodium. That is how we wrote sodium here. We began with the number of electrons. We counted the electrons was 11. It was having 11 electrons. That is why we use that to fill up the shells here. Let's write the electronic configuration of magnesium. Magnesium is Mg. Mg. So I can use the symbol to represent the nucleus with it. This is a symbol of the nucleus. Yes. So I'm going to draw the first shell of magnesium. And the first shell, we have agreed that the first shell should take 2 electrons, right? As proposed by Niebol. 2 electrons in the first shell. The second shell of magnesium should be able to take 8 electrons. First of all, how many electrons does magnesium have? Let's write it. Magnesium is on position 12. It's having a proton number of 12, atomic number of 12. So electron number will be the same as the proton number, which is 12. So we are going to fill a total of 12 electrons following this same pattern. 2 electrons here, 8 electrons here, and the remaining one comes at the valence electrons. So this is 2, 1, 2, 3, 4, 5, 6, 7, 8. Yes, the second shell have taken 8 electrons already. How many are left? Now 2 electrons are left to make of 12. These 2 electrons are going to come outside. Looking at this structure of magnesium, you can know that these are the valence electrons. Magnesium has 2 valence electrons and has how many core electrons? 10 core electrons. All the electrons apart from that in the valence shell. Okay, let's take another one, which is chlorine. Let's talk about chlorine. Number 2, chlorine. Yes, let's represent Cl as the nucleus of chlorine. How many electrons does chlorine have? Chlorine is on position 17. Chlorine 17. So it has 17 electrons. Use those electrons to fill up the shells following this same pattern. 2 electrons in the innermost shell, 8 and 8. Yes. So the first shell, let me use the first shell, or use the first shell of chlorine, and 2 electrons are going to be placed in the first shell. Yes, you can decide to pair them. Yes, and the second shell is taking 8 electrons, provided electrons are C enough. If this one takes 8 electrons, electrons are C enough, right? Yes. 2, 8, which is 10 electrons already. So how many electrons are left? Pause that and give me the answer in the comment section. We have 7 electrons left. So 1, 2, 3, 4, 5, 6, 7. That is chlorine. I believe this concept is well understood right now. When you are writing this, it's not the electronic configuration yet. It's simply the representation of those electrons on the atom shell. So electronic configuration does not need you to be drawing these structures. You have to just know that 2 electrons goes in the innermost shell, 8 electrons come here. So the innermost shell, let's represent it with 2. Like I said, this is being represented by numbers or using numbers. So 2 electrons in the innermost shell, 1, 2, and 8 electrons, and the other one is how many electrons? 2. Yes. For magnesium, this is the electronic configuration of magnesium. 2, 8, 2. You can see that a magnesium is not stable because it's supposed to have 8 electrons in the outermost shell, but it's having only 2. So it needs 6 electrons to be stable. For it to be able to have these 6 electrons, it must combine with some other atoms through what we call chemical bonding. And we are going to be learning detailedly about that in this channel. So stay tuned. Make sure you subscribe to this channel so that when that video is being released, you'll be the first person to get notified and watch. Now let's write the electronic configuration of chlorine. We just drew the structure of chlorine, showing how electrons are being filled in the shell. Let's write the electronic configuration. Now, electronic configuration of chlorine, let me use 2. The first shell is having 2, right? So it becomes 2. You should not add more than 2. It begins with 2. And the second shell is having how many electrons? 8. Third shell is having 7 electrons. This is the electronic configuration of chlorine. If you have understood electronic configuration, there is no need for you to draw this structure whenever you are being asked. For example, if I say that you should draw the electronic configuration of oxygen, you know that oxygen belongs to position 8, right? Oxygen belongs to position 8. So you are going to consider that oxygen has 8 electrons. These 8 electrons, these are they are being filled up. Phase shell takes 2 electrons. Now, how many electrons are left from 8? We have 6 electrons. The 6 electrons are left. You can see that this is the electronic configuration of oxygen. And oxygen is not stable because this shell was supposed to take 8 electrons, but it's taking only 6. It's having only 6. It's not having other electrons to fill up to 8. Now, let's give another example. The last example, let's talk about calcium. Write the electronic configuration of calcium. Calcium belongs to position 20. Calcium is on position 20. So it's having 20 electrons, 20 protons. We are using electrons to fill up the shells. So we are not going to draw this structure again. The first shell takes 2 out of 20, 2. The second shell takes a maximum of 8. The third shell takes 8. You have used up 18 electrons. So how many is left to make up 20? 2 is left. This is how electronic configuration are being written. If you have understood this concept, just write at the comment section, I have understood the points, before we continue. Having known this, our next objective is how we can relate these structures with the periodic table. Two families are divided from the periodic table. Two families. What are the families we are talking about here? You have two families known as the periods. The first family is known as the periods, and the second one is known as a group. Periodic table is divided into periods and the groups. Generally, valence electrons simply represents the group of an element on the periodic table. When you know the valence electrons, you automatically know the group of an element on the periodic table. For example, we say that magnesium has 2 valence electrons. It means that magnesium belongs to group 2 on the periodic table. Valence electrons is equal to the group of an element on the periodic table. Number of shells is simply the period of an element on the periodic table. Valence electrons, the group of an element on a periodic table. Number of shells is equal to the number of periods or the period of an element on the periodic table. So let's choose a random example of an atom. You are going to give me its periods and the group of that atom on the periodic table. Let's choose carbon. Carbon is a simple atom. Yes, carbon. What is the number of electrons of carbon? Is having 6 electrons, right? 6 electrons. How can you fill up these electrons? The first shell takes 2. The second shell is left with 4 to complete 6, right? So this is the electronic configuration of carbon. Looking at this electronic configuration, you notice that the valence electrons, how many valence electrons is carbon having? These electrons are on the outermost shell. 4 electrons are on the outermost shell. And how many shells is carbon having? 1, 2. Carbon is having 2 shells and 4 valence electrons. 2 shells and 4 valence electrons. So you can conclude that carbon is on group 4. Carbon belongs to group 4 and period 2 on the periodic table. That is how we can relate electronic configuration and the periodic table. Let's choose another one, chlorine. Let's talk about chlorine. Like we said earlier, chlorine is having 17 electrons, which is 2, 8, and 7. Yes, how many valence electrons is chlorine having? Chlorine is having 7 valence electrons. The electrons at the outermost shell is 7. So it belongs to group 7, right? It belongs to group 7. How many periods is chlorine having? So the periods you're counting the number of shells. This is the first shell, second shell, and this is the third shell. So this is 1, 2, 3. Chlorine is on period 3 on the periodic table and group 7. You can always relate this. Let's talk about something like calcium, which is 2, 8, 8, 2. This is calcium, right? Pause this video and give me the number of shells of the calcium on the periodic table. How many shells is calcium having? Without drawing the structure, you automatically know the number of shells of calcium. Calcium is having 1, 2, 3, 4. 4 shells of calcium is having 4 shells, which is period 4. Calcium is on period 4. And how many valence electrons? The last electrons is the valence electrons. 2 valence electrons, which is the group, is on group 2 and period 4 on the periodic table. Let's talk about the last one, which is potassium. The last example I will be giving is potassium. Potassium is on position 19, which is 19 electrons, filling up the electrons. You're going to use 2 in the first shell, 8 in the second shell, 8 again, because this is 18, right? 2 plus 8 is 10 plus 8 is 18. So 1 is left, 1 comes outside. This is the electronic configuration of potassium. So looking at this, how many shells? 1, 2, 3, 4. 4 shells. And how many valence electrons? Carbon is having only 1 in the outermost shell, which is 1 valence electrons. This all about this video. We have attained all our objectives. So if you want to keep on receiving more videos in chemistry, physics, mathematics, and other sciences, make sure you subscribe to this channel so that you are not going to miss any of my video which is going to be uploaded. And don't forget to drop a like, to hit that like button. Drop a comment at the comment section.